Okay, so this is the proof of de Moivre's theorem by induction. So what we're asked to prove is we're asked to prove that cos theta plus I sine theta to the power of n is equal to cos n theta plus I sine n theta for all n elements of n. So just a quick note. No, actually, let's just go straight into it. So the first value we put in for n is 1. So let n equals 1. So cos theta plus I sine theta to the power of 1 is equal to cos 1 times theta plus I sine 1 times theta. And yeah, when you do this to the power of 1, you just cos theta plus I sine theta is equal to cos theta plus I sine theta. Okay, so it's true for n equals 1. Okay, now as usual, we assume true for n equals k. So I assume true for n equals k. So we're saying that cos theta plus I sine theta to the power of k equals cos k theta plus I sine k theta. Okay, it's our assumption. And then this is what we have to prove. So we have to prove that cos theta plus I sine theta to the power of k plus 1 equals cos k plus 1 theta plus I sine k plus 1 theta. Okay, so we'll actually begin this proof with what we're trying to prove. So in this case here, we're going to start with the left-hand side of what we're trying to prove, which is cos theta plus I sine theta to the power of k plus 1. Okay, now what we're going to do is we're going to take that left side and break it up. So that's the same as saying cos theta plus I sine theta to the power of 1 multiplied by cos theta plus I sine theta to the power of k. Okay, so when we're multiplying, we would add those powers there, and that's how we get our k plus 1. Now you'll just notice that this part here is our assumption there. Anyway, our left-hand side stays the same. I'm not going to rewrite it every time. All I'm going to do now is apply the de Moivre's theorem just to this bit here. Okay, I'm just going to apply the de Moivre's theorem to this. Why? How can I just apply de Moivre's theorem to this? Because that's what I have here in my assumption. Okay, so I'll apply my de Moivre's theorem to the thing that I know. So cos theta plus I sine theta to the power of k is that, and I know it's equal to that from my assumption. So that is cos k theta plus I sine k theta. Alright, so again, I'll just multiply this out now. So cos theta by cos k theta is cos theta cos k theta. Cos theta by I sine k theta is, we'll throw the I first, I cos theta sine k theta. Then I sine k theta by cos k theta is I sine cos k theta. And then finally, I sine theta by sine k theta is I squared sine theta sine k theta. And we'll remember now that I squared is minus 1. So I'll bundle my reals together. The reals are the parts without i's, so this has no i's. And this will have no i's because I squared is minus 1. So there I'll have cos theta cos k theta, and I squared turns to minus 1, so minus sine theta sine k theta. And then I'll have my i's together, these two. So I'll have plus I cos theta sine k theta plus I sine theta cos k theta. There should be a theta up there actually. Okay. Right, I'm going to factorize out my I there. So I have cos theta, cos k theta, minus sine theta, sine k theta. Factorizing out I here, that gives me cos theta, sine k theta, plus sine theta, cos k theta. So now we have a look at our tables and we'll see if we can spot anything that looks a little like this and spot anything that looks a little like this. So I want cos minus sine sine, cos minus sine sine. So here I have cos A, cos B minus sine A, sine B could be written as cos A plus B. So that would be, so all this in red here would be cos A plus B, so it would be cos of theta plus k theta. Plus, and then I've got my cos sine plus sine cos. Cos sine plus sine cos. Cos sine plus sine cos. Yeah, so cos sine plus sine cos. Well, here it's sine cos, cos sine, but that's the same as sine cos, sine cos. So either way, it's sine A plus B. Perfect. So we'll write that down as the sine of theta plus k theta. All right. Don't forget, actually, I have an I in front of that, an I there. Okay, so where are we here? So my final line, so my left-hand side, bring it all to the end. I had to prove that cos theta plus I sine theta to the power of k plus 1, equals. Now, what I'll do is I'll factorize the theta out of this, so I have cos of theta times k plus 1, or if I want I can write that as k plus 1 times theta. 1 times theta. So imagine if I multiply the theta back in, I'd get k theta and I'd get 1 theta. And then finally plus I sine k plus 1 times theta. Okay, so that's your proof. That's exactly what you're asked to do up here in blue. So it's true for n equals k plus 1, and then finish off in the usual manner.